Hi there, it's Professor Monty. We're looking how to solve a polynomial inequality using a sign chart. Follow me. All right, so here's the steps that we're going to go through. First, we need to set it to 0. So if the polynomial is not set to 0, we need to set it to 0. Then we're going to factor it out, and then we're going to find where each factor equals 0. These are called the critical values. And this is a key step that we do, and we use this same idea in calculus. If you go there, you'll use it there as well. Okay, now we're going to put all the critical values on a number line and then check a test number between each critical value and outside towards infinity on each side to see if it's positive or negative in the inequality. And then when the inequality is less than, if that's what we're looking for, we're going to take all the negative intervals. And if we're looking for greater than, we're going to list all the positive intervals. That's going to be our answer. So let's look at an example. So I've got this, and I notice I don't have 0 on one side. So the first thing I'm going to do is just subtract the 15x. So I get x cubed plus 2x squared minus 15x not equals less than or equal to 0. All right, now I need to factor that out. And I see they all have a common x, so I'll factor that out first. I get x squared plus 2x minus 15 less than or equal to 0. And this factors nicely. Two numbers are multiplied to negative 15 and added 2, positive 5, negative 3. Okay, so I've got it fully factored out. Sometimes they start this way, which makes it a lot quicker, obviously. But what I'm doing is I'm setting each of these equal to 0 and solving. So I know x is equal to 0 and x equals 0. X equals negative 5 is going to make that 0, and x equals 3 is going to make that 0. These are my critical values. And so what I do is I do a sign chart. Here's how the sign chart works. We'll put it right here. I put all these numbers on my sign chart. Of course, I do them in order, negative 5, 0, 3. And what I'm doing, this is breaking up the number line into 1, 2, 3, 4 intervals. I'm going to put my fully factored thing up here. All my factors, I'm going to go x, I'm going to go x plus 5, I'm going to go x minus 3. So there's all my factors. I'm going to list those and I'm going to put signs up. I'll show you in a minute. And then down here, what I'm going to do is what happens when I multiply all these all together. X times x plus 5 times x minus 3. Okay, so now what I do is I get a test number someplace furthest to the left, say negative 6, somewhere in between, say negative 1, somewhere in between, say positive 1, and somewhere to the right, 4. So these are just test numbers. I'm testing these. I'm plugging them into each of my factors just to see if it's positive or negative. I'll show you what. So if I plug in negative 6 here, I just get negative 6. I don't care the number, just the sign. If I plug negative 6 here, I get negative 6 plus 5 is negative 1. Again, just the sign. And negative 6 minus 3 is negative 9. And I'm going to do that for all the test numbers. So I plug in negative 1, I get a negative 1 there. Negative 1 plus 5 is positive. Negative 1 minus 3 is negative 4. Plug in 1, positive 1. 1 plus 5 is positive 6. And 1 minus 3 is negative 2. Plug in 4, positive 4. 4 plus 5 is positive 9. 4 minus 3 is positive 1. And now what I'm doing, remember, I want the product of all these multiplied together. Well, a negative times a negative is a negative, but times another negative, negative times a negative is a positive, but times another negative is a negative. So my product of all three of these signs is going to be negative. Here I go, negative times positive is negative, times another negative is positive. Positive times positive is positive, times another negative is negative. And then 3 positives multiplied together is positive. And remember, what I'm looking for is where this is less than or equal to 0. Well, when the y value is less than 0, means it's negative. It's below the x-axis. So I'm looking for negatives. And so I say, well, where's my product negative? Oh, here and here. So I want this interval, and I want this interval. Since I have the equals, I keep both of these, and I keep this. And so my answer looks, that's the graph of my answer. So I'm going to go all the way negative infinity, all the way to negative 5. Remember, list your critical value because that's where it was equal to 0. So if I plug in -5, and then union 0 to 3. Don't plug in your test numbers in your answer. Plug in your critical values. I get some students mess that up, but it's an easy fix. All right, so that's the idea. Hope that helps practice these. I'm only going to give one example because I know you can pause and you can go back and figure this out. Try some on your own, though, because the more you do, as always, the better you'll get.